Hey everybody, this is Larry. This is day 29. Wow. Almost there to the end. 2 more days. One after today. 2 more days and going today. To the to the end of the month. So hit the like button, hit the subscribe button. Join me on Discord if you'd like to talk about this problem. Start next month on a good note, or just hang out. Have a lot of good people here. Just chilling and stuff. But yeah, okay, 785 is graph bipartite is this one. Oh, also, just to give a quick update, I've been doing that a little bit lately, out of order, but that's my bad. Is that whoops, that away. I did put in a band-aid, so for those of you who asked me about it, thank you. I'm okay. It's just a scrape. It'll be okay. It just looks kind of nasty. That's all. All right. That's what they said about my face. Oh, okay. Anyway. Focusing on the problem here. All right, there's an undirected graph with endnotes. I mean, honestly, just looking at the title probably is self-explanatory. Each node is numbered from 0 to n-1. You're given and there are no self-edges. I mean, and it's fine if there is. It's just the end is going to be no anyway, right? Like if there's self-edges, there's no graph bipartite. There are no multiple edges. Again, that doesn't actually change anything. So it wouldn't matter anyway for a bipartite graph. I know that these are additional properties, but I'm also just mentioning that if you just think it through, and I'm just thinking about it live, so it's not like I prepared for it, but if there are self-edges, then the answer is no, obviously, because, it just connects to itself. If there are parallel edges, it doesn't change the value because you can just, if you just do a parity type argument, that's not going to change the parity of the edges, right? So of like the cut edges or whatever. So it should be fine. If V is in graph, okay, so this is undirected. It just means that it's a symmetric thing. That's fine. It also doesn't change anything. The graph may not be connected. Oh. Okay, so this one actually makes it a little bit interesting, but that's fine as well. If there are two nodes, U and V, such that there's no path between them. Okay. Yeah, I mean, that's fine. It's just now instead of a I was going to say a forest, but that's not true. It's just it's just disjoint graphs, and let's see how they define it. If the node, okay, so I mean, that's fine. That means that each connected component would act within each other. And here, again, there's a couple of things you can do. There's connected components for sure, because you have to make sure that, everything is, you have to separate it out by the connected portions, because, or you don't have to, but it will make it easier. But the other core part about this is greedy, right? In the way that I'm trying to think whether it is something that I know innately or something that like I had to learn the proof for, because I don't remember whether I just know it, right? But the idea is that it's greedy, right? That means that if you have a node, you make it one color, then all its neighbors have to be a different color, and then all their neighbors have to be a different color, etc. Right? That's the definition of bipartite. You could also sort them into the left or the right, or whatever, black and white, however you like to do it. And then if there are any two adjacent nodes with the same color, that means that you're almost like a proof by contradiction type thing. So that's basically the idea we're going to go through, and that's the idea that we're going to do. I know that people, I would say also that I've been more active in using like visualization and drawing and stuff like that. If you're a long time viewer, you'll maybe notice that. But I feel like that's a good enough verbal visualization, right? Like greedy and just look at adjacent nodes. So hopefully, let me know if you have any questions. But I think, yeah, it's just a contradiction, right? Meaning, for every node, you give it any color, and then that means that all its neighbors have to be a different color, and that means that almost like an induction type thing. Except for that, at the end, if there are two neighbors that are at the same thing or same color, that means that it is a contradiction, right? So that means that it cannot be happen. I know that I've used the word color, and I don't think I described it, but another way to say a graph is bipartite is that it's two colorable is another way of saying it. So that's why I use the color terminology. And this is graph theory stuff, but also probably basic algo. So my apologies if I'm using weird vocabulary or vocabulary that you might not be familiar with. But let me know in the comments or in the Discord if you have any questions about it. But yeah, I mean, I think that's going to be good enough for us to get started. And also keep in mind that in this case, for each independent, for each component, it doesn't matter what color, because I mean, they're really, if it is bipartite, then if you color one node white, then all the node on the other side is going to be the other color. Or if you color it black, all the other node on the other side is going to be white, right? So it doesn't really matter in that sense. So let's get it started. That's all, something like that, right? And then we have colors as you go to I didn't even look at is it just an adjacency list? They didn't actually really the grab of use. Okay, so yeah, so that means that I can do this is what I was gonna try to figure out. So then here we have let's also label it I was gonna say uncolored, but what's like a blank maybe default, I don't know. Whatever, it doesn't really matter, right? So something like that, right? And then now you could do it a couple of ways. You could use breadth first search, you could use depth first search. I'll use breadth first search. Wait, I guess I use so let me take a look. Okay, constraints are 100 is fine. Because the reason why I usually but to be honest, when I was first starting out, I find depth first search more intuitive because it's just recursive, and I've always been a little bit better at recursion maybe. But the trade-off in this case with depth first search versus breadth first search, and this is why I look at the N, is the recursion depth, right? Because every time you do recursion, you accumulate whatchamacallit, right? Like you get core stack and you just use more memory as a result. And usually it's fine. Because the algorithm that we're doing is going to be linear in the size of the number of edges, v plus y. But let's say, and this is something that I not gonna lie, in contest and etc. Given practice, I've kind of I ate it, you could say. If you're not familiar with slang, then that means that like I made a mistake and made the wrong answer. Because when n is, say, in this case, it could be, say, 10,000, right? Or 100,000, say. If you're going to do a recursion on 100,000, on some languages, especially Python, one, it may have stack limit. So it'll be like, oh, you hit the core stack limit, recursion limit. And then two, even if you don't, let's say you set something, sometimes you run out of memory or something like that. So very often now I use breadth first search for that reason, unless I know the bounds. And in this case, n is 100, which is fine for either way. But I'm going to use breadth first search because I think it's easier to keep the scope for a reason that you'll see in a little bit, maybe. But yeah. But then now, before we write that though, we can just write out the loop. So for I of n, if colors of I is equal to blank, then we how do I want to say it? Yeah, maybe I just write something like if to colorable of I, or if this is not true, then we return false. Otherwise, we return true, right? Actually, man, I just remembered that like 2 or 3 weeks ago I did something similar, but I forgot to do part of the caching, and that was a very quick and free 5-minute penalty. It was very sad. So anyway, so yeah, so to colorable from this node. I know I'm being inconsistent with the U, so let's actually make this. Let's do it the American style. I grew up on the other style, so sometimes I go back and forth. But yeah. Okay. So then now we use this is going to be breadth first search. So let's start by using a queue. And this is, I hope this makes sense, right? Is the graph starting at start connected to colorable, right? Again, I don't think about the I kind of vaguely talked about the complexity and really thought about it. I'm trying to do a better job of explaining before I start coding. But the idea that with these connectivity problems, breadth first search is going to be v plus y, where v is number of vertex and y is the number of edges, and that's going to be linear. So if it's linear, it's going to be fast enough. So that's why I didn't really look at the constraints that harshly. Yeah. So yeah, so we append start, and let's just say we start colors by using, let's say, oops, let's just set it to white. It doesn't matter, right? So then now we do, and then current is equal to right? And then now, of course, this is the current index. So then now look at all its edges, pretty much. So for v I use v because it's like UV notation, but I don't know if that's actually that good. But yeah, so the two things we have to check. One is if colors of v is equal to colors of current, then we return false. That means that if it has the same color as its neighbor, then it's false, right? Technically, I'm going to also add something to make it less confusing, though this never happens, right? This will never happen. This part will never, or these things are always going to be true or false together. The reason is because current will never be blank, so it has to be blank for it to equal each other, or it has to be not blank for it to equal each other. But I just want to write it out to be more, you know, like just to be more clear for my folks at home, but also so that you don't have to prove anything. Like you can just do it, right? Like you look at the code, you're like, okay, this makes sense. But yeah, otherwise, if it is blank, then colors of v is equal to, I guess you could do some like funky math trick, and honestly that's probably usually what I would do, and maybe I would change the constant so that it's easier to do that math trick. But in the spirit of trying to make it more readable, I am going to try to just write it out, right? Also, I just realized that like black and blank is like only at a distance of 1 away, so it seems like it's very easy to make a mistake, but oh well. That's it. And then at the very end, oops, if we are able to go through the entire subgraph without it, then it's returned true. So yeah, so now I feel like we are able to go. Ooh, yikes, I guess. Huh. Dun, dun, dun. Oh, I'm dumb, damn I? Because I looked at the wrong thing. So this is if the current color is right, then we want the JSON to be black, not, I don't know why I wrote it that way, but that's okay. That was a quick fix, and also, that was a quick spot actually, but also it works now. Let's give it submit, let's see how it goes. Cool. 759 streak, yay! Okay. Yeah, like I said, this is going to be v plus y, even though you may ask yourself, oh, there's a for loop, and each of these do maybe v plus y. Well, each edge is going to only be looked at once here, and each node will be only processed one, which is here, right? So that means that it's going to be v plus y, even though, you know, like the summation of all those subgraphs will be v plus y. So this is going to be, let me just write it out for visualization. And of course, it's going to be all v space because we keep track of the color. That's pretty much all I have for this one. Let me take a quick look to see what I did last year. Did I did breadth first search or depth first search? Oh, I did the same thing actually. Yeah, well. No, I did white, red, blue for some reason. Was it like, I don't know. But otherwise, everything is the same idea pretty much. Oh, and I've cached next color, so I don't have to write this if statement. Okay, fine. Yeah, so same idea though. Yeah, let me know what you think. Friday's here, so have a great weekend. Stay good, stay healthy, to good mental health. I'll see you later. Bye bye.